calendar week 37 log. I'm going to be shooting some of those videos now, hopefully on a weekly basis. I want to keep a log of my progress week by week, and I think that's a bit of a it's a reflection tool for me, but it's also hopefully a tool that will allow you to also, those of you who are not like following every single video, at least to kind of get a sense of what I'm doing every week and you know, how is the whole project going on. I'm going to be splitting those into 3 separate sections. One section, the first one is going to be a brief introduction to what I've done in the previous week. The second section will be basically the highlights of the videos and the highlights of the stuff that I've learned during the videos, maybe things that you can take away, maybe things that you can go and look for in the videos. And I'll be hopefully hovering the videos while I speak, so you kind of, you know, I'll link them on the actual video with one of those YouTube fancy things that pops up on the left or on the right of the screen, and then a final section with an off-screen sort of, basically the idea would be to get the stuff that I don't manage to put in a video because I'm tweeting about these or I'm thinking about these, and you know, maybe things that I dream while I sleep, I don't know, stuff that are quantum related but I don't really manage to put them in a video. I'll hopefully be able to put them in the section so you can also get a grasp of what's going on in my head. Having said that, let's get started with the first calendar week progress log. It's week 37. Now it's week 38, but I'm going to be talking about the previous week. And yeah, as an introduction, I've done 3 videos. They're all of them pretty long, about an hour and 30 minutes at least. The reason that I shot such long videos is because I wanted to accomplish at least I wanted to feel like I accomplished one thing in each session. I'm still working on the portfolio optimization project from Multiverse Computing and Chicago Quantum. So, you know, I'm basically at the point where I really want to make sure that there's some steady progress. That's the reason for the length of the videos. In terms of highlights, you know, 3 videos, 3 takeaways, to be honest. In the first video, I finally started to get the coefficients out that I wanted to put in the Cubo. I was doing this with SymPy. I started 2 or 3 videos before that, but because this is the first log, I'm going to mention a bit more of the background here. The idea is that with SymPy, you can specify you can work with symbolic language. So you can work with actual equations like with variables, x, y, etc. And so the paper defines a pretty complex, it's not complicated, but like a really compact equation that then they, you know, use to actually build the Cubo. And in order to do this programmatically, the best idea I had was I would use something like SymPy, which I really hadn't learned before, I hadn't touched before, and so I had to learn this on the go to take and build this equation, then expand the equation, and then take the different coefficients that I can, you know, put in the right place in the Cubo matrix. If you want to know how that went, just check out the first video. It was basically about this. The second video, I got the whole thing to work with D-Wave. Now, the equation is not yet fully done. I just did a portion of the equation, the easy part of the equation, but I wanted to check whether at least, you know, shooting a Cubo to D-Wave would really give me something. And I haven't even verified the results yet, like whether they actually minimize the function, the equation, but at least I got something end-to-end tested. And on the third video, I started diving into tensor networks for 2 reasons mainly. So first one is I thought this had to do with the branching idea that I've been recently talking about, where where control NOT gates, or you know, control operations create branches in your system, in terms of, you know, if qubit 0, your control qubit is 1, then apply this operation in qubit 2, the target qubit, and that kind of creates this branching. And so, but it really, this was nothing to do with this. So it's basically like tensor networks is just like, instead of working with, you know, monster tensors, you just take them apart and actually work with smaller tensors that are connected within a network between each other. And what these connections mean is usually, you know, the actual matrix product, for example. And so in theory, they should be easier. Like these should be easier representations to work with. Now, this is the video was just getting started with the topic. So that video is really about reading an introductory paper and trying to find stuff online. And now in the video that I'm going to shoot after these progress log, I'm going to be getting my hands dirty with it at the code level. So we'll see where this goes. And that's it for the highlights. Stuff that I've been thinking about, maybe not, stuff that I haven't really been able to put on a video. I've been thinking a lot about entanglement recently, other ways that one could represent a quantum state. As I said, the branching idea, right? I've been thinking a lot about building also a simulator based on these. Just for myself, not really, I don't want these to do the standard thing, like the standard linear algebra, or just I don't really care about the performance. I feel like I want to try to understand a bit more what can you do with, representing a state with just the isolated qubit states and also then the entanglement between them. It's proven to be a bit tricky because I've been thinking a lot recently about just like 2 qubit gates, and that works well. I tweeted about like Grover's algorithm, from a branching perspective, and it works well. But as I started trying to think about it from with a Toffoli gate, for example, like what type of branch does this create? I got a bit stuck because I kind of realized that now you don't have a simple branch, but you have a branch where you've got 2 control qubits. And so how do you do that, right? Is it like a branch with 2 legs, or is with like it's like a deeper branch? But I think that if instead of doing these, I try to just decompose the Toffoli, and I use the decomposition that it's based on T gates and control NOT gates, and I work these out, maybe I'll get to something interesting. So we'll see. And what else? I enjoyed a lot in this week reading about like singular value decomposition and matrices as bipartite graphs, and that was a post from, I hope I won't pronounce her name wrong, Tai Danai Bradley. She's basically running the Twitter with the handle Math3MA and a blog with the same name, if I'm correct. And I really liked it because it actually connected. It was a bit of a coincidence, but it connected a lot of those topics. It really talks about the entanglement or mathematical representation of entanglement, as in like that's sort of the thing in between the 2 matrices that you're taking a bit matrix, that's your state, and you're kind of separating it, but there's information that stays in the middle that you can't. Like in the singular value decomposition, you have like these 3 different components, and the component in the middle is just a diagonal matrix, and that's kind of where you have this entanglement represented. And then she connects that with tensor networks as well. So I found these really, really, really cool. And I think that's it, to be honest. It's been a bit of a busy week otherwise, but really focused on that stuff. And I think for the next weeks we're going to be really focused on these projects still, but we will be. I'll try to really squeeze in a couple of couple of videos now and then where I'll just do some tangent stuff as well. We'll see. Hope to see you guys soon in the next progress log. Calendar week 38 will be.